Today I'd like to talk about what I've been working on over the last couple of days for the Redis 2022 hackathon. So what I've built is called a geocoder. Geocoder is a service that takes in a string representing an address or a latitude-longitude pair and resolves it to an address or a set of valid addresses that are the best match based on some heuristic. Typically, this heuristic uses either geospatial search or full text search to resolve sort of the query address to one of the valid addresses. So here I'm using 1 million addresses from New York City, storing them in Redis, also using Redis as my full text search engine with Redis search, and geospatial search as well. I think it's easiest to just get into a demo because that can really explain how powerful this service can be. So I've got my server up and running on my website, and I'm going to send a request that has the word Pacific spelled wrong, hoping that it will resolve to Pacific Street spelled properly. And what we find is that the server can understand that this is not how you spell Pacific. We have, Levenstein distance reconciliation going on here, and we get out, a valid address with Pacific spelled properly. We can also use the server to score results. So in this case, I'm using the address 200 West West Street, and I get back 10 results. Each of them has a score counting down from 1, where the best one, is a pretty close match, and the last one is, still a very close match, but less so. Based on what your client application does, you can filter that as needed. And then finally, I'd like to get into what we call reverse geocoding, where we submit to the server a point and then get back the same series of addresses, but using geospatial rather than full text search. So in this case, I'm querying for a location, 40.677. Let's just look at the latitude. And then let's parse this. And what we see is we get back an address that's got, almost identical coordinates, probably within a few meters of one another. So let's get into the architecture of this system. So all traffic for this service goes through a load balancer that's hosted on DigitalOcean. Everything is hosted on DigitalOcean. We hit an edge HTTP gateway, and that service checks Redis to see if the result of the query that the user has just sent is cached. If it's not, it forwards it to an RPC service that actually issues an FT search against a Redis mod instance with search. And if it's a reverse geocode query, then it does still an FT search, but with a geospatial filter. Once that gets a result, we parse it and send it all the way back to the user, like you saw in the previous section. So this is great, but it doesn't really address the fact that a lot of time that when we have invalid addresses, we have dozens or hundreds of them. So I also worked on building out a service that deals with handling addresses in batch. So the architecture of the async service is a little bit more complicated, but it's really powerful, so I think it's worth going through. Just like the synchronous requests, we hit the load balancer and then the edge service. And then rather than hitting the gRPC service directly, the batch requests go through to a batch request service. The batch request service creates a UUID and then immediately sends back to the client a message that says, I've created a UUID. This is the UUID for you to reference when you want to check the status of your request. In the background, what we're doing is persisting that UUID in a batch status cache, which is just a hash in this batch status cache in Redis, saving the request body to DigitalOcean spaces, and then firing off a message to an event bus. On the other side of this event bus is a service called Async Worker. What Async Worker does is retrieves the file from DigitalOcean spaces, serializes it, and then streams it to the geocoding gRPC service. This connection, because it's using bidirectional streaming, is really fast, and we can send requests far faster than sort of a user can send them through to the HTTP service. So this is why this is preferred for handling dozens or hundreds of requests, right? Rather than spending 60, 100 milliseconds on each round trip to the edge service. So once the async worker has finished geocoding the service, or once it's gotten all the geocoded results back, it sends a status message back to the batch service, which has a background process that is updating the cache. Along with that message, it passes what's called a signed URL. A signed URL allows a private file to be temporarily viewable. So that signed URL corresponds to your results in DigitalOcean Spaces. So let's say 5 seconds later, 10 seconds later, when the client comes back and they hit status again to get an update on their process, they'll see status complete and then the signed URL. And then they can go decide when they want to pull all of the results later. It's going to be available for at least a day. I haven't got a hard TTL, right? So let's go into what this looks like in practice. So I've created this batch request that is going to contain about 100 partial addresses. These are all things that will probably trigger a match, but none of them are valid. Things like Mason Street, Sutphin Boulevard, East 39th Street. None of these are going to be perfect matches, but they will trigger something on the search index. So let's just go ahead and take this file and send it to the batch endpoint. And I'm going to save the UUID to this variable UUID. So we see the result, UUID, status 1 for accepted, and then a update time, which indicates that this is when it was accepted. So a few seconds later, we are going to request the UUID, and we see status 4 corresponds to success, download path, and then update time is when it completed. So difference between 42.19, 0.76 probably took around 500 milliseconds to complete 100 properties, locations. So we can now pull that download path using JQ and then take a look at the first 10 results from the batch. And what we see is that we get 10 perfectly good geocoded results. DeVoe Street goes to 236 DeVoe Street, 69 Ave goes to 6069 69 Ave, Barnard Ave goes to 151 Barnard Ave, things like that. We can also do reverse geocoding, and I have a few sample files that you can play with. In this case, we're going to send a bunch of requests that are latitude longitude requests, and it'll be the same process. Independent of any of the architecture that I've talked about so far, I've also got a Redis Insight instance running along with my deployment. Here we can see sort of everything that's in that Redis search instance that's doing all of the heavy lifting. So we can see that we have just under 1 million keys. Each of them contains just a location and a composite street address. We build the FT index on both location and composite street address, use location for geofiltering, composite street address for sort of term frequency, full text search things. And yeah, we can go to the overview and we see we've got 500 megs, million keys. Yeah, that's really about it. One of the places that's kind of interesting would be to expand this data set. We're using 500 meg, but of course we're only looking at New York City. There are probably about 50 million addresses in the U.S., so this could very easily be 25 gig, but that could also fit on a pretty reasonably sized instance if you really wanted to. And from Redis Insight, we can do all of this sort of memory profiling, things like that. Yeah, that's about it. Thank you for listening.